Hi, I hope you're having a good day or night wherever you are. In this video, you're going to learn how to read binary code. Now, binary is a system it's a number system that we use to communicate with computers. Now, you'll notice I have an example of what binary code might look like. Usually, binary code is a very large number of digits that look something like this. And we use binary to communicate with all computers. That's how computers process information. Anything that has existed on a computer, like your phone or laptop, or anything that processes information, like a thermostat, a printer, a calculator, all of that information it processes, whether it's a picture or words or sounds, must be translated at some point into binary code in order for the computer to understand it. Binary code is a number system different from the number system that we are used to, and that number system is called the decimal system. Deci meaning 10. Now, if we were to count up to 10, you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And a few things I want you to notice about this sequence of numbers. Notice that in order for me to go into larger amounts, numbers that represent larger amounts, I needed to add another digit. So after 9, notice these first 9 numbers are 1 digit, and then the number 10 is 2 digits. And if I wanted to make a number larger than 10, I would need 3 digits, like 438. Or to make any number larger than 99, I would need 3 digits. 99 would be the largest number we can make with just 2 digits. So for me to make bigger and bigger numbers, I need more places. Now that concept is relevant to learning binary, so I just wanted you to notice that about this system. The second thing I want you to notice about the decimal system is that there are 10 digits. There's the digit 1, 2, or 10 symbols that we use to represent all the numbers in the decimal system. When we have an infinite number of numbers that we can represent, but we really only use these 10 symbols to represent them. This symbol, 2, 3, 4, 5, 6, 7, 8, 9 symbols, and then 0 is the other symbol that we use. And then we change the combination of these symbols to represent amounts of something, how many cookies you ate, how old you are, how many days have passed by since Friday the 13th. And so we use combinations of these symbols to represent numbers in the decimal system. In the binary system, there are really only 2 symbols we use, and that's actually why it's called the binary system, because bi means 2, just like with a bicycle has 2 wheels, or if you're bipedal, you walk on 2 legs. A binary system only uses the symbol of 1 or 0 to represent all the amounts. So if you see 2 ones close together, like here, if you're reading this as a decimal number, this translates into the number 11, or 11 dots. 11 cookies, 11 days, 11 years, 11 puppies. That's how you would represent that amount using the symbols from the decimal system. Now in the binary system, if we said this 1 and 1 are binary digits, this would not represent 11. It would represent something else. And so we're going to learn how to translate binary numbers which use 1s and 0s to figure out what amounts they actually represent, because we don't read them the same as our regular numbers. So for our introduction to binary, we're going to be working with 5 places. Now, if this were a decimal system and I had 5 digits, for example, this number here, that's a 5-digit number. In decimal, it would represent the amount 52,104. So this is a decimal number with 5 places. We're going to be working, just as our introduction, just as practice, with 5 places of binary numbers. Now, this is going to, let me just tell you, it's going to feel a little weird at first. But just stick with me, it will make sense by the end, I promise you. So just like with decimals, the the most right place always represents the smallest amount. So we're going to pretend that each place actually can represent up to, or does represent a certain number of dots. So let's say if the rightmost is representing the smallest amount of dots, smallest amount of anything, it's going to represent 1 dot. The next place to the left is going to represent 2 dots. The next place is going to represent 4 dots. The next place after that will represent 8 dots, and the next place after that will represent 16 dots. Do you notice a pattern? What pattern? How would you describe that pattern? As you go from right to left, notice the number of dots increases. Does the number of dot increase by the same amount or at the same rate? This number of dots is representative for a binary number. Each place represents a certain number of dots. As you go from right to left, the number of dots doubles. And that would be true if we added another place. But for now, we're only going to work with 4. So can you guess what how many dots would be on the next card if I were to add one over here? It would be a card with 32 dots. Okay, now stick with me. You're probably still wondering, what does this have to do with binary? We're going to practice with we're going to see our first example. Now, binary can be represented as a 1 or a 0, remember? Those are the only digits we have. So the way that is related to these dots is when the dots are showing, we're going to say that that digit is on. And if we say that digit is on, that represents a 1. So in this first example, let's say I turn off the first 2 digits. So those are zeros. If the digits are off, we're not counting the dots. That means that digit represents a 0. And if the dots are on, if they're showing, we're going to count them, and that represents a 1. So let's turn off all the digits except for the middle one. Example 1. This number, as you see it right now, represents the binary digit 0, 0, 1, 0, 0. Now, if you're looking at this like a decimal number, it might look like the number 100. It is not representing 100. That's what it would be if it was decimal, but we're trying to learn binary. We're going to say this is a binary number, and it actually represents the amount 4. And how do I know that? I just look at the number of dots that are turned on based on where the 1 is, in which place the 1 is. Let's look at another example. Let's say I turn on this one, let's turn off this one, and let's turn on both of these digits. So now this example shows the binary number 0, 1, because now this one's turned on, 0, 1, 1. Now again, as the decimal, this might look like 1011, but it is not. It does not represent that amount. We're looking at it specifically a binary number. And to find out, can you guess? Can you see the pattern yet? Can you guess what this binary number actually represents, what amount it represents? So we have to count the dots. So here there's 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this binary number, oh, that's not how you spell 11. This binary number represents the amount 11. Starting to make sense? Okay, now I want to know what's the largest number I can represent with these 5 cards. So I'm going to turn them all on. I'm going to count them all. So now we're looking at the binary number 1, 1, 1, 1, 1, 1, 2. And by adding up all the numbers, or all the dots, I mean, we could do this with a calculator, you can do it in your head. I've done it ahead of time. By adding up all these dots, we get the amount 31. That means this 1, 1, 1, 1, 1 is the largest number I can represent with 5 places. In order for me to represent an amount that is larger than 31, I would need another card. I would need another place. Just like if I wanted to represent a number larger than 99, I would need another place to have a 3-digit number. Okay, so now from here, you can tell that we can take the binary numbers and translate them into amounts that we can then write as decimal numbers if we want. But then how do we go from that to making pictures or sounds? Well, once we have the actual number, like in the last one, 31, we can say that that number represents the color red, or that number represents the capital letter F. Or we can say that number, we can assign it to the value of E flat. I don't know how to write E flat, but it could represent a sound. So then the computer is able to read these ones and zeros so quickly that we can give it a lot of information, a lot of different colors or sounds or letters to translate very quickly. And that's all the computer's processing. So let's practice translating numbers, in decimal numbers, into binary numbers. Now this might be a little trickier to work backwards. So let's say I want to represent the amount $21 in binary. So I have to figure out how do I turn these dots, turn these cards on and off so that I end up with an amount of 21. This is me thinking out loud now. There's 16. What combination can I make so that I have 21 dots? And you may be able to figure it out. I think you will. I think 16 plus 8 is going to be bigger than 21, so I don't think the 8's going to be on. 16 plus 4 make 20, and then I could add the 1 to make 21. So in binary, the number 21 is 10101. And that 21 could represent a letter or a sound or a color, and then the computer just needs to know that this is the binary code for that amount. Let's do another example. How do I represent the number 14 in binary? The amount 14. So if I want to so how would I show the amount 14 in binary? I need to find out what combination of these 5 cards is going to give me 14 dots. So if I add 8 and 2, that gives me 10. So I have to get rid of that one because that one's too big. And if I add 10 with 4, that's gonna, okay, so this is gonna, the binary number for the amount 14 would be 01110. Pretty cool, huh? So you're gonna practice on your own now how to translate binary code to your name. So you're gonna have a chance to assign different letters, different amounts to binary code working with these 5 digits. I hope you learned something cool today about binary code. Binary is life. Really, if you use any computer, any device that processes information, you have a device that is using binary code to give you a picture. Or in anything you translate over the internet, it has to exist in some form of binary, and computers can process so many digits. Now we use 5 digits in our practice today, but typically computers, they take in chunks of 8 digits at a time. We call that a byte. when you have 8 of these numbers together, we call that a byte. And depending on how many thousands of bytes your computer processes each second, that's the processing speed. Depending on how much your internet is able, so if you look at internet speeds, that could be like 20 kilobytes per second. That's a measure of how many of these ones and zeros your computer is able to get from the internet each second. So it's very relevant. I hope you find it interesting, and I hope it inspires you to learn a little bit more about how computers work. Thanks.